What I want to do today is kind of do a brief overview of end behavior. And behaviors. And how it kind of correlates with stuff that we've done in the past. In Algebra 1, we probably spent some time talking about linear functions. This is a graph of a positive slope line, and this is when m was greater than or 0, is positive. And then we kind of, if I graph this equation of this line, or graph of this line, hopefully all of you realized that your slope was negative. It was less than 0. We could talk a little bit more like it has a y-intercept, and that's pretty much the extent of it. Now, but let's talk about the end behaviors of these graphs. What they're referring to is what's at the end of this graph, right here, what's happening. So they're asking, as x gets bigger, x goes positive, goes to positive infinity, as I go to the right of my graph. So if I follow along and I keep going to the right of my graph, what are my y values doing? Hopefully most of you can realize that my f of x, or my y values, get bigger also. Okay, and let's talk about the left side of the graph. As it gets smaller, as it approaches negative infinity, as it gets smaller and smaller and smaller, hopefully y'all can agree that this is when I'm going to the left of my graph, that my x's are getting smaller. They're approaching negative infinity. As x's get smaller and smaller and smaller, what are my y values doing? Well, my graph's going down. My y, which is f of x, it's approaching negative infinity also. Okay, that's end behavior. That's what we're talking about here. And same thing, let's talk about the end behavior if the slope is negative. So, let's do this portion of my graph. As x gets negative, as my x's get smaller and smaller and smaller, my y's, which in pre-calculus we're not going to call y's anymore, we're going to call f of x, they're getting bigger. They're getting bigger and bigger and bigger. Okay, on the right side of the graph, hopefully y'all can agree that you understand that I'm not going to, this is positive 1, this is 2, this is 3, this is 4, 5, 6. So that's what I'm talking about here. As my x's get bigger, as they approach positive infinity, as I take my graph and go positive infinity, my y values, or the end of my graph, they're getting negative. That's a little bit easier, sorry guys. They get more and more negative. Can't seem to fit on that paper. Sorry. Okay, hopefully y'all can get this. Okay, this is end behavior. We spent a little bit of time in Algebra 2 doing that. And but what we're going to progress to is we're going to go on and talk about and define end behavior using limit notation, which again, it's just the same thing, it just makes it a little bit more neat. It's asking as the limit of, as x approaches positive infinity, f of x equals positive infinity. That's for this right side of this graph. On the left side of the graph is the limit as x gets to negative infinity, my f of x approaches negative infinity. These are just an easier, neater way of writing what ends of my graph are doing. See? I kind of took up the whole graph defining that, but I can write my notation, and that's what end behavior. This is how you notate end behavior. Okay, that was the end behavior if my slope is positive. Let's write the end behavior of this line if my slope is negative. I'm going to write it up here. So, as limit as x approaches negative infinity, so as my x's approaches negative infinity, my y's are going to positive infinity. Okay, on this right side, as my limit approaches positive infinity, as my graph goes to the right, my f of x, or my y values, still running out of room, Miss Andrews. Sorry. Limit as x approaches positive infinity, f of x equals negative infinity. There we go. Okay, now that's if it's a line. Let's talk about the end behavior if it's quadratic, or let's talk about what the graph's doing if it's quadratic. Alright, so in Algebra 2, or actually Algebra 1 and Algebra 2, we talked about quadratics. Here's a quadratic. It opens up, and this is quadratic, opens down. Okay, now in linear equations or graphs, we used the slope, we use the letter m. Okay, but they actually, it doesn't make a difference whether it's m or whatever, but they start using the letter, the coefficient in front of the leading term, they call it a. So this is a graph when a is positive. This is when, that means the quadratic is opening up. So if I use y equals, just make this up, 2x minus 2 squared minus 2. That's what, if this is the equation of this graph. Just totally made it up, but it's okay. This a, this is the leading coefficient, that's your a, that's positive. If you have an equation like this, y equals negative 2x minus 2 squared plus 5, this your a term is negative, so this is where a is negative and the graph opens down. Alright, but what I wanted to talk about was the end behavior of these graphs. So we're talking about what is happening. So when this graph is opening up, my a is positive. What are the ends of my graph doing? Again, as I go if I start and go to the right of my graph, if I'm going this way on my graph, as x's get bigger, as they get more positive, what are my y values doing? Well, they're going up. Well, how we denote up is positive infinity. Right, on the left side of my graph, as x gets negative, that's what we mean by the left side of my graph. When my x's get smaller and smaller and smaller, my y's are getting bigger. So the nice thing about something that's squared, when it's an even function, even powered, my end behaviors are going to go in the same direction. They're either going to go up, up, or down, down. Well, on this one, they go, because a is positive, both my y values are getting more and more positive. They're both going up, up. Okay, a nice way or an easy way to denote this is all well and good, but the good notation is the limit as x gets bigger, approaches positive infinity, my f of x equals positive infinity. On the right side is the limit as x goes to negative infinity, f of x equals positive infinity. Okay, that's the end behavior notation. Still can't spell, sorry. Alright, Now let's talk about the end behaviors of my quadratic if they go down, or when my a is negative. So again, it's asking what's going on the left side of my graph and what's going on the right side. In Algebra 2, we just kind of use the notations that I have up here. As x's get positive, as I go to the right of my graph, my y's are going down. How you denote the down is negative infinity. Right, and this one on the left side is x is going to, they're going smaller as my x is going this way. So I'm going more and more and more and more left. My y values are going down, which how we denote down is negative infinity. Well, that's the notation, and if I can write that on a graph, that's fine. But the limit and behavior notation, how I'm going to write on this graph, is I'm going to erase this just to give myself some room. This is when a is less than 0. Okay, the limit notation for this, limit as a, okay, the limit as x gets bigger, my f of x is getting smaller, going to negative infinity. And on the left side is the limit as x approaches negative infinity, f of x is getting smaller also, negative infinity. So this is how you do the end behavior if a is negative. This is a negative infinity, guys. Make that a little bit nicer. Still not very nice. Okay, there you have it. This is end behavior. So if it's going down, this is the end behavior. If your a values are positive, and that is if your power is positive. If they're 2, 4, 6, 8, all those even power functions, their end behavior is either going to be up, up, or down, down. If it's up, up, that's how you write the end behavior right here. It's positive. This is if it's down. Your end value is down. Okie dokie. And the last function that I want to talk about in reference to end behavior is rational functions. This is what a rational function looks like. This is f of x equals 1 over x. And one of the things about rational functions is it has they have a vertical asymptote and horizontal asymptotes. And when we did rational functions, and this is pretty much where we started talking about end behavior, and why it's important, end behavior is important for rational functions, is because the end behavior is defined by horizontal asymptotes. So, if I was to talk about this one, this is this end behavior. So as x gets bigger and bigger and bigger and bigger and bigger, as x gets more positive, what are my y values? What is the graph actually doing? It's not going down or up or anything. What's it actually approaching? On this one, because it's the parent rational function, it's approaching its horizontal asymptote, which is 0. And then on the left side of the graph, as x goes left, gets smaller and smaller and smaller. As x gets smaller and smaller, let's see if I can write this better. What are my... Okay, sorry about that, guys. What's this doing? It's approaching 0 also. So let's write this in limit notation. And this is end behavior, how you define end behaviors but in limit notation. So on the left side is the limit as x goes to negative infinity. My y values approach 0. On the right side is the limit as x approaches positive infinity. My y values are going to 0. Okay, that's the parent. That's for this rational function. Let's do it if it's negative. If I go this way. This is negative. And there again, this is an odd function, but anyway, silly because it reflects over the origin. But this is if I have my graph looks like this. This is equation f of x. F of x equals negative 1 over x. That's where my leading, this number right here, my a value is negative. It reflects it over the, actually reflects it over the x-axis. Okay, so, but I'm going to write the limit notation. Again, it's asking us what's going on when x gets more and more positive, what's my y values doing, and then as x gets smaller and smaller, as it goes to my left, as it goes, my x's get more and more negative, what's going on there? I'm just going to skip straight to the limit notation. As x's get smaller, as I go to the left portion of my graph, my x's get smaller and smaller and smaller, my y values are approaching its horizontal asymptote, which again, this has a horizontal and a vertical asymptote. So that's what if its x's are getting smaller, and lo and behold, the other thing is going to hold true, is if my x's get bigger, I'm going to run out of room again. Sorry, guys. Is the limit as x's get bigger, approach positive infinity. And there it goes. F of x equals 0. Okay, I'm just going to erase all this so I have room, sorry. Alright, limit as x gets smaller, f of x equals 0, and as the limit approaches positive infinity. F of x, again, approaches 0. Still ran out of room, but anyway, that's when you have a horizontal asymptote. Okay, just a basic review on end behavior. And why that's important is because we're going to talk about end behavior for different types of functions, whether their powers are odd or even, or if their powers are negative, like rational functions.